Today we're exploring the world of enterprise power distribution units, starting with this APC AP7830 from 2005. I'll go over my current retro rack power setup, or lack thereof. We'll fire up this AP7830 and look at its remote management through the serial console and over a web server, and I'll think through why this isn't quite right for what I have in mind. Then we'll prototype repurposing some industrial panels to create a future retro rack power control center using some ESP8266 microcontrollers. Let's get into it. This is an APC 7830 PDU, or Power Distribution Unit. Its main purpose, obviously, is to be racked up in a server rack and provide a convenient spot for all the equipment to get plugged in and receive their power. Obviously, it's meant to be mounted vertically in the rack, usually at the back of the rack, and it's kind of hard to get in frame here because it is over 5 feet long. They're also used for monitoring power usage. Here's a little amps display here, the current, and there's a couple ways to interact with it. We've got an RJ45 network port right here and a funny little serial port, so we'll definitely be looking at that. And depending on the unit, you can actually, with the software that runs on these, remotely power on and power off individual switches over the network. But let me show you what I'm dealing with in the rack in the other room to give you some context for why I'd even want something like this. And we'll see, this might not be the one I need. This is the retro rack. I've got networking gear up top, some Sun Microsystems servers in the middle there. At the bottom, I've got an IBM hub servicing something called an HMC network, not important for this video, with some P5 and P6 series enterprise servers from the mid-2000s. And I've got a power issue. This whole rack is literally powered with this extension cord, which runs under the door out of the room I'm in to another circuit, because over here, where all the outlets are, this is a 15 amp, 120 volt outlet powering that whole rack. And basically, if anything with an inrush current, so you plug a machine on and it draws a bunch of current really briefly, I don't know why, but it flips this GFCI outlet here. This is a GFCI outlet, and the whole rack turns off. I'm kind of confused as to why that happens, because I don't think that inrush current should do that, but it does. And so what I need to do actually is get a 20 amp outlet over to there and redo that, but that's another story. For example, even just plugging this cute little guy in, a little Sunfire V120, plugging it in, not even powering it on, just plugging in the power supplies is enough to overload and aggravate that GFCI outlet and get it to flip. The breaker doesn't flip, but the GFCI outlet doesn't like it. So yeah, it's a mess. I've also got this 240 volt service. In fact, let's measure it. Let's measure this bad boy. 240 volts, almost exactly. Remember that for later. That's important as I'm exploring the PDU options I have for this equipment. Oh, also, that's not a real tattoo. I was a 3-year-old's birthday party this weekend, and we were all getting tatted up with temporary tattoos. I got a sweet elephant on my arm. The main power distribution setup is this little switch, and so this is 15 amps, 120 volts. That extension cord is plugged into this, and I really like it. I will tell you, it is incredibly satisfying to come in here and flip these switches and watch this stuff turn on and vice versa. But what I'd really like to be able to do is both switch things in here and remotely with a more sophisticated PDU like what we're going to explore today. It's also just a little bit of a mess. I'll show you the back before we leave this room. The network stuff is in those first few switches, and that's all pretty stable now. I'm not moving that stuff around, so that's always there. But when I'm plugging in like the servers down there, or even these Sunfires you can see, I kind of randomly just reuse some of those ports. And so I need more outlets for sure, and I need a kind of a tidier setup. This isn't going to do justice for just how bad this is, but it's a total mess. I'll show you some pictures going straight on from the back. So over the course of this video and many future ones, this one's going to be mostly exploratory and experimenting. We're going to figure out how to dial in the power situation and the switching and everything and monitoring for the retro rack, and eventually also make progress here. So I'm going to do away with this 15 amp deal, and we'll put in some 20 amp service, 120 volts, but 20 amp. I'll get more 240 volt stuff going on. We'll talk about that a lot in this video. And yeah, really just try to improve everything. It's a total mess. I picked this thing up when I bought a Sun Microsystems server rack from a local viewer named Josh. He had been using it to power gear in that rack, and he let me take this with a lot of stuff I bought. But after getting this thing on the bench, I've learned a little bit more about PDUs, and I'm afraid this particular one might not be quite right for what I've got in mind in the retro rack. There are two basic types, at least in my experience with the way APC likes to market things, and those are metered and switched. Metered simply means you can see how much power it's drawing, and I suspect gather that information over the network for aggregation elsewhere. You can see the one we've got here, metered rack PDU. Switched, on the other hand, means you can remotely administer each port, turning them on and off as you wish. I don't believe this one does that. We'll find out together, I guess, but I'm pretty sure it's just a plain old metered PDU, and when you plug this thing in, they're all on all the time. If you're looking to buy these things online, the usual dead giveaway that it's switched is each port will have an individual LED telling you if it's on, and obviously in this metered PDU, I don't have that. Another problem, and I knew this when I bought it, it's only 120 volts despite this very large, chunky NEMA connector, which we'll look at later, and I'd really like to use 240 volts. Most enterprise computing equipment can actually handle a large range of voltages. For example, this is a spare power supply for one of the servers I have in the rack, and if we zoom in right here, it will happily accept between 100 and 240 volts and put out all the outputs that the machine needs. And even if we take a look at something like this little Cisco router, it can also operate anywhere between 100 and 240 volts. There are several advantages to having higher voltage service in the rack, and a reason it's done in data centers, one of which is that higher voltage you draw less current. Now, you aren't saving on electricity. The same amount of power is used in the end, but less current means less heat. The other advantage, for me anyway, is that some of my devices actually require the higher voltage. For example, the massive IBM P5 machine on the bottom of the rack here, it won't fully boot on 120. It needs at least, I think, 208. Which leads me to another problem I didn't even know I had. If we flip this thing around and take a look at the sticker on the back here, we've got this model AP7830, and right here in this little chart we know that it is 120 volts. And as the model numbers go up, we get into voltages higher than 120. But that's 208. I don't have 208. I have 240 volts. And then if we keep going, we see this pesky little 3 here. That stands for three-phase electricity. I definitely don't have that. I have what's called single-phase or split-phase power to my house, and I can happily make 240 volts with it, essentially adding together two of these 120 volt standard outlets we have here in North America. It's a little more complicated than that, but essentially I can definitely get 240 volts. In fact, let's measure this one. It should be about 120. Let's put that on AC. That's important. Let's get in there. So yeah, 116 volts. And basically I can add two of these together, and I have in the other room, to get close to 240. So I have 240, but I don't have 208, which is what these enterprise PDUs are rated for. Too bad I didn't know that when I ordered a 208 volt unit, which is on its way from eBay as we speak. Data centers typically have something called three-phase power, from which it is easy to derive that 208 volts, so I suspect that's why they use that. The answer to this problem is something called a buck boost transformer. One of these things can take 240 volts in and turn it into 208 volts going out, or something close enough anyway. So I did the right thing and ordered the cheapest one I could find on eBay. This thing must weigh like 15 pounds. It's very heavy. The listing said it was new old stock, so I don't think it's been used before. My goodness, it's heavy. Come on. Oh, wow. This is an Acme Electric General Purpose Transformer, T181058. I believe this can go from 240 volts to 208 when it's configured correctly. Oh, and 15 pounds was a very good guess on my part. That is exactly what it weighs. And I'm almost certain it's never been used because none of the knockouts have been hit, so it definitely wasn't in use, which is great. And so basically brand new and should work just fine, and I'll hook it up, and what could go wrong? But those are future plans. I kind of have a vision for how I want the power distribution to take place in the retro rack. But in the meantime, let's see if this thing works. We should be able to get in over the serial console, and if the password isn't default, there is a little reset button right in here, and I was reading in the documentation that APC still hosts on their website, to their credit. You can do a little reset procedure, and then theoretically, this thing is hosting some sweet, mid-2000s web GUI for us to take a look at over the network. We'll figure that out. Let's plug this thing in. The first hurdle is simply going to be plugging it in. You can see it's using this big, I think it's a 30 amp NEMA style locking connector here. NEMA stands for U.S. National Electric Manufacturers Association. Even these style are also NEMA connectors. And hopefully you can see right there it says it's an L5-20P. The L stands for locking. I'll show you later, but these can kind of actually twist and lock into their receptacle. 5 is the amount of current carrying lugs and the wires added together. So we've got 1, 2, plus 3 wires for 5. 20 is 20 amps, so it's rated for 20 amps. And then P means it's a plug. It's got prongs coming off of it. So I bought its counterpart here, and hopefully, there we go. Anyway, you can push those in and you can kind of twist it and it locks so that it won't pull out. That's what the L and the L, whatever that was, 520p means. And now we can just plug her in. Signs of life. You got the orange light here. Hopefully it's just booting up. I saw the network port flash a little bit. Okay, that's looking a little healthier. It's displaying 88 amps. I imagine it's still booting. And then we've got a green light on the network link port there. It's kind of funny to think that this thing is like sort of a computer. Has to boot up. About 5 minutes later and it says error. That's probably fine. We'll see if it's providing power, shall we? Sure looks like it. This thing just turned on. What's this do? Oh, you can just ignore the error by clicking this button. She's up. This cabling is pretty industrial. Our next hurdle is this serial port. This is going to let us remotely interact with it, hopefully see what that error stuff is about. Haven't tried it yet. And typically, in a data center, you would have an RJ45 serial port, same form factor as a typical Ethernet network jack. Obviously, they didn't do that here. It's something slightly smaller. I think I see 6 pins in there maybe. So that's kind of annoying, but not to worry. I have pulled out one of my boxes of crap. I can't possibly be the only person that has a million of these USPS boxes just all over the place, full of stuff. A bunch of this stuff was sent in by a viewer named Larry a long time ago. And I've got one of the cables I need, for sure. And then it was a bunch of, like, stenograph stuff. I don't have the steno machine or anything like that, you know, like for shorthand in a courtroom. But I've got some of these. This one, convert it to serial deal here. You can see, I think it said, yeah, it's got the stenograph brand on it. I don't have any of the steno stuff, but I kept all these adapters because they can be pretty handy. Hopefully the pinout is what we need here. Oh, and this cable was in this Manhattan Finest Quality Computer Products bag. Look at that. Anyone remember those guys? What else is in here? Ooh, floppies, sweet. Yeah, a bunch more of these cables. Oh, more APC stuff for protecting your wires from surges and your laptop. That's funny. I didn't know this was in there. Okay. So we will get this plugged in to the serial port, and then we'll do the usual song and dance of converting that back over to USB. Something tells me I need this null modem. Let's find out. The moment of truth. Here we are in the serial console. Nothing. I'll be back. I removed the null modem. Oh, okay. Yeah, that worked. I think I was reading it's APC by default. That was easy. Okay, here we are. Copyright 2004. This thing was end of life several years ago. So yeah, this is a pretty old unit. Let's see here. I want to see, like, you know, errors or something. About system. Cool. Okay. Manufactured March 10th, 2005. And it's running in something called the Rack PDU app. The type is stat app. Okay. We can reset to defaults, all that good stuff. Device manager? Power supply status. It says it's okay. Control L for the event log. Ooh. Okay. It thinks that it's March 25th, 2019. That's fine. So it's complaining about communications lost. Maybe that error just means it's not on a network. It doesn't like that or something. I'm not sure. So that's all I can find in here. Okay, let's see if we can find out what IP it's on. This is pretty straightforward so far. I don't know what I'm doing, by the way. I'm just poking around. TCP IP, it is on a 1050O network, and its IP is .10, and its subnet mask is 255.255.254. Okay, well, let's get a laptop hooked up to that thing and poke around. It's getting a little meta. We're going to power this little switch in this Windows 7 laptop with the PDU itself. And I made a little network here, physically anyway. We'll power up this machine and we'll get it on that, I think it was 10050 network, whatever it is. I'll double check and get this thing an IP on that one. And hopefully we should be able to see whatever this thing's hosting over the web browser. All right, got this thing on the same network as the PDU, theoretically. Let's start by seeing if we can ping the thing. And we can, that's a good sign. And now we're going to try to hit it in the web browser. Ooh, yes, APC. Oh yeah, baby. Look at that. It'll show you the load. Obviously, we're not drawing a lot with this laptop and that little switch. Here's that event log. So I'm guessing that error we saw on the display at startup is it just can't get on the network. And it sees us here having logged in. That's interesting. That even after I've logged in, it's complaining about communications lost. Maybe it does have an issue. Well, there you go. I just wanted to see this. It's definitely metered. We obviously can't turn on individual outlets or anything like that. It just knows the total load, and you can figure, like, you know, alerts for if the current is getting too high, and it'll, well, let's see what that even looks like. Yeah, low load, so if something's wrong with your machines and it's not drawing enough current, you can get it to complain to you. I would have expected some sort of like way to get data from this thing, like SNMP or something like that. You can apparently configure custom links that show up down here in the left. So you can link off to your intranet or whatever, your IT stuff. Well, it works. It seems like it's healthy, but I don't know if I'm going to use it yet, or at least not at this moment. I'd really like to have switched outlets. I want to be in this room, and I want to be able to power up portions of the retro rack as I need to without going in there, and be able to monitor, what's on and all that. I'm really hoping that 208 volt unit I got off of eBay is going to be able to do that. And if it can't, I'll just find one that can. I'd really like to be able to have like an API or SNMP to be able to control it with some software I write myself. So I'm going to get this stuff cleaned off, and I'm going to go over my plans for how I'd like to power the retro rack and interact with it. A little sneak peek for you there. But first, I would be remiss if I did not go over at least a little bit of the history of APC, because it's a pretty big name in data center power. APC, or American Power Conversion Corporation, not sure why they dropped the last C in the logo, was founded in 1981 by 3 electronic power engineers from MIT, at least 2 of which spent time before 1981 working at MIT's Lincoln Laboratory, which is actually a very well federally funded lab that devotes most of its efforts to national defense. In fact, the SAGE project came out of the Lincoln Laboratory, SAGE being the Semi-Automatic Ground Environment, a Cold War-era project launched in the late 1950s to aggregate the data coming from geographically dispersed radar installations to provide an overall view of United States airspace. The SAGE project interests me especially because Bell Labs, Western Electric, IBM, and others were heavily involved. IBM being the primary manufacturer of the AN/FSQ7 computers, which initially powered SAGE with their over 60,000 vacuum tubes inside. So it's interesting to know that the founders of APC have at least a partial connection via the Lincoln Laboratory. Anyway, APC started in solar power. I guess that didn't work out. Then they transitioned into UPSs, or uninterruptible power supplies. Basically, big batteries that keep your stuff running properly when the power is unstable or goes out entirely. By the 1990s, APC was an absolutely massive name in the data center power business, and they were eventually acquired in 2007 by Schneider Electric for $6.1 billion. APC operates with the same branding and name they always had as the Critical Power and Cooling Services business unit of Schneider Electric. Okay, so hear me out. I want to have a remote panel in this room, and I can remotely press a button like that or something, and all the networking equipment will turn on. And I want to have a system such that I can relay information about the system back. So maybe an alarm if there's no network. Status would just be, the routers are on, the switch is on, something like that. And so I was looking around online, and I came across these Liebert System3 panels. They're for like huge industrial AC and power distribution units, I think. And you can find quite a few of them on eBay. In fact, there are 2 of them. I wasn't sure what kind of shape they would be in. And this one has its full wiring harness. It was obviously just ripped out and cut off of this one. So we'll be able to reuse this cable, some of these maybe. And I guess the deal was you'd have different numbered units. This is actually really nice printed onto metal. I'll talk about my future plans in a moment, but this was like clearly like a sticker you could put on, so unit 7, unit 11, or that's what I'm guessing anyway. I don't really know anything about these. So for the rest of this video, we're going to do a little prototyping. I was kind of messing around here, and I noticed that if these two pins here are connected and I flip the switch, that is the switch, so those are the two pins I care about there. And I don't have the PDU I need, so I need a PDU that I can click a button here, have a little Raspberry Pi or something on the back that remotely interacts with the PDU and tells it to turn on certain things. I can read whether those things are on, and then I'll drive these LEDs. Hopefully this is making sense, but today we're just going to do a little prototyping, I think. Let me show you what this thing's all about. So here's the front, and we've got quite a few LEDs to play with, and I'll either find color matched stickers maybe, and I could just put that on, or more likely I'll probably measure all this out, recreate it in Illustrator, and take this front bezel off and overlay it myself. This could say, I don't know, Collab Retro rack panel or something. I'll definitely keep this aesthetic. I like how this panel looks. We've got a very simple controller board, and I thought I was going to have to reproduce all this. I thought this was going to be more sophisticated. In here, it's just, you know, a ground plane and then some resistors into the LEDs. You can't just hook an LED up right to 5 volts or whatever. It'll burn out eventually. And yeah, down in there you can see it's just the inline resistors with the LEDs. Very simple. The other one is slightly more sophisticated. There's like a resistor pack or something. I don't think that's really a IC chip doing anything interesting. And then here they just had the resistors with the LEDs there. So that's my backup. I got another panel. This one smells horrendous, unfortunately, and it's not in as good a shape as the other one. So I haven't thought through a final system yet, but I think I'd like to use some ESP32s. These are ESP8266s, sort of like really cheap little microcomputer deals. And I've got a bunch of them. Yeah, they're like dirt cheap. That's the whole thing. They have Wi-Fi, which is great. So this can connect to a Wi-Fi network, and I can write some software for it to talk to let it inform me when I've pressed the switch or what LEDs to show. That'll be in a future video because I don't have the PDU to do this with, but I've got a couple of these development boards, and they've just got the ESP8266. There's its little Wi-Fi antenna on the left there, mounted to a dev board that you can put USB into and flash it. And then when you're ready for production or whatever, you mount one of these up to a flashing board, and it's a much smaller footprint. I will realistically probably just use these. So you can control a bunch of these pins, GPIO pins, to either listen for voltage or output voltage. So the first thing we're going to do is I need to refresh my memory. I haven't programmed one of these in like 3 years or something. Let's just get it blinking an LED. And then we'll prototype interfacing it with this panel and at least getting one of these buttons firing an LED and see if these work. Yeah, let's do it. Okay, I've got it shoved in the breadboard. I've got power. These run on 3 volts, which might be an issue for those LEDs on those older panels. We'll see. Unfortunately, you can't. I don't think you can get 5 volts off these. Maybe this dev board gives me 5 somewhere. And then ground, of course. And then we're going to make, let's see here. Let's do pin D4 and D5. We'll have one of those be the LED output, and we'll have one of them be an input pin we'll listen to see if a button is depressed. I think that's what we want. Doesn't look as good, but I like using these loose ones when I'm prototyping. So what did I say? D5 and D6, I guess, are the pins we get to deal with here. So let's move them out where we can access them. Maybe something like this. We're going to use this one as our button, and I have it pulled to ground, meaning when I'm not giving it power with this wire, it's going to be in an off state. And basically, if we want to simulate a button click, we'll give this one power. Okay. And then this is really simple. So D6 coming out here through a resistor so we don't burn up our LED. And I guess I want that going to ground, don't I? That's why you got to double check your work. So now programmatically with software, we can give this green wire power, and it'll turn on the LED. It might do that in its default state. They might all just be pulled up. Okay, now I gotta go refresh my memory about how to program this thing. Let's write some code to interact with our physical prototype here. I like to use a Visual Studio plugin called Platform IO. It basically has all the drivers and takes care of a bunch of headaches when it comes to interacting with these small little microcomputers. And if you've ever programmed for an Arduino, it's basically the same thing. It's literally the same functions. So I'm gonna define some constants. Let's go through this line by line. And hopefully it'll make sense. So the LED pin, our output pin, is D6, and the input, our button that we're simulating is D5. And then the way this works is when the microcontroller starts up, it runs a function that you've called setup. It will run this once, and then it will run a loop over and over and over again. And that's your main entry point. And so in setup, I'm setting the LED pin to an output pin and the input pin to an input. That's just how you do it on these things. And then I'm telling it to start a serial console so we can see some logging over the console here that you'll see in Visual Studio. Now, after it runs setup once, it's going to go into this loop. I'm putting the LED to low, meaning I'm turning the LED off, and then I'm reading from the input pin. If the input pin has voltage, aka it's high, then I'm going to turn the LED on, and I'm going to spit out to the serial console, the button was pressed. Otherwise, I'm going to turn the LED off, and I'll say that the button was released. And then I wait 200 milliseconds, and the whole loop starts over and over again, which gives you basically what appears to be to the human eye real time. I haven't done this in like 3 years. We'll see how this goes. But basically, we define our pins. We have an LED output and a button input, and then we're just looping, and we're saying, is the button being pressed? If yes, turn on the LED. If no, turn it off. I'll bring a shot of our prototype board online here, and so Platform I/O is really nice. I'm just going to say upload and monitor, and in this terminal down here, it's like, maybe I have to double click. In this terminal down here, it is going to compile my program and put it on the device. So you can see, maybe, yeah, there's a blue LED that's actually built into the computer, and every time it's writing, it's flashing the blue LED. So far so good. And you can see the green LED is on, so it's stuck in like a high state, just on, you know, whatever default was going on here. And now in the serial console, it's just saying button released every 200 milliseconds. And if I did this right, I'm going to give my button power. All right, so as long as there's power, we can see the green LED turns on, and when I pull it away, this little pull down resistor is draining it, so to speak, and turning it off. Excellent. Okay, it's still sitting there running its program, hopefully. Let's see. Yes, we can turn that LED on. So now what we're going to do is run power through this switch, and it will actually gate. And this is going to be a little janky. It's these brown wires. I don't have the right test connectors here, so bear with me. Okay, so I'm touching the 2 brown wires, and we should be able to turn it on. Oh yeah. This is going to be so sweet. So I know it doesn't seem like it, but that is the baby steps to being able to tell this button to tell this microcontroller to tell a PDU to turn some stuff on. Been trying to get these LEDs to do something, and I have a little bit of a mystery on my hands. So this big trace here is the ground, and it goes to the bottom 3 pins here. So if I'm over here, this is one side of the 4 green LEDs on the front. That beeps. That is ground. What this means is that positive should be over here. So this trace goes all the way like this to here. It jumps a resistor over to here, follows all the way back over to pin 4. So pin 4 is on the other side, right there, of the resistor for the top green LED. But I can't get it to do anything. This thing has 3 volts coming off, and if I just do ground there, you'll have to trust me that I traced these wires right. And 3 volts there. Nothing. We don't get anything on that LED, and this is on, so let's see if our button is still working. Yeah. So that has power, but I was thinking, okay, maybe 3 volts isn't enough for whatever these are. So we'll get out the bench power supply, and we want the 4th pin to be positive, and any of these last 3 pins can be negative. And we'll hook that up and hopefully not short anything, power him on. And if I get it up to 5 volts, 6 volts, nothing. I went all the way to 10. They're like 300 ohm resistors in there or something. Like 100 something on that side and 300 something on this side. Different LEDs for some reason. And yeah, I'm getting no action whatsoever. Both panels have the exact same behavior. I'm going to take it off somehow. It's hard to believe anything could have gone wrong. This is such a simple board. Okay, I'm gonna get these little bolts off. Yeah, not a whole lot of surprises. It's literally just inline resistors to the LEDs. So I guess what I can do is I can try applying, well, I know the circuits are good. Sorry, I'm thinking out loud here. Let me mess around. Oh, dude, I'm so stupid. The polarity is reversed from what I thought. What I kept calling the ground plane and ground traces, that's where the power should be. So check this out. Beautiful green LED. We'll leave all that in. I'm going to put this panel back together and see if we can get something cooking. And they will happily run on 3 volts. 3.3 volts, I guess. Well, there you go. Okay, so picture this. I come downstairs. I'm ready to do some retro computing. Bam. I get an LED telling me that my network is being powered. I got an alarm saying I can't reach the network yet. You can imagine that goes away after all the stuff boots up. That is the future. But that project doesn't really matter until I have a switched PDU I can use. This 208 volt unit just showed up this morning. And remember, I don't have 208 volts to give it, so I can't actually use it yet, but we'll unpack it. Let's have a look at, I'm hoping it's actually switched. It's a 16 port unit and it does say switched down in there, and I can see there are LEDs for each switch, so that is good. Look at this power cable. And right there, 208 volts AC, 24 amp unit. You know what? Let's plug it into 120, see what it does. Ah, just kidding. We'll have to wait. It's a slightly different style NEMA connector than this 120 volt power rated cable I've got right here. So the story ends here for now. Well, that's probably for the best anyway. This video was kind of all over the place, but I think you see the future plans here. We'll have this remote panel in here mounted probably on the wall behind me so that I can use it. And then when I get 208 volt service in the other room, we'll see if this switched PDU is going to work for me, if it works at all. Wanted to throw it out there that I'm going to be at VCF Midwest next month, Saturday, September 13th, 2025. So if you see me, definitely say hello. As always, I hope it was fun to follow along as I messed around down here, messed around with some microcontrollers, PDUs, different power stuff, repurposing a Liebert System3. But that'll do it for this one. If you haven't already, please consider subscribing. It's the best way to help the channel grow. And I've also got a Patreon. I post the occasional early video and what I'm tinkering with. If you're going to be at VCF Midwest next month, I hope I see you. But otherwise, I'll catch you in the next video.